Hello, everyone, and welcome to another Dev Remix Weekly. Forgive me for not playing our cool intro countdown video. I misclicked that button. Here today with me as not as always is me. Not with me as always is Tim, who is charting a busy course. Vacationing and then traveling to a whole bevy of events. So let's go ahead and go through some of the news, and then we'll be talking about some changes and improvements that have been made recently to the dependency vulnerability check recipe. And this will be a good one to listen to or watch if you were interested in how that recipe is implemented. If you want to maybe make your own kind of dependency vulnerability check, or kind of generally get under the hood with that. In honor of Cybersecurity Awareness Month, let's begin. To start with, a couple events coming up, or a couple of new blog posts, new things to share. On the Moderne blog, we have posted this customer journey that MedHost, one of our customers, has gone through, interviewing with them with how they use Moderne and how they use recipes in order to save a lot of time and money and eliminate a lot of TDM from the software development process. So do check that out. It's on Moderne.ai under the resources blog section, and I will be sure that a link is posted in the description for that. So beyond that, we have a new Rewrite GitLab module, which is now a place to put recipes relevant to the GitLab source control system, and particularly around manipulating GitLab CI and such. It's pretty bare at the moment, but if you are a GitLab user, then we enthusiastically welcome your contributions. As for upcoming talks, if you are in or near Belgium, our own beloved Tim Tabik will be presenting at Devox soon. And let's see, on Monday. What's the exact date for this? It is. Missed the date. Yeah, so okay, so it's going to start on Monday, October 7th. I do not know if any registrations are still available for that, but if you are interested in attending that, look forward to it. Tim is a great speaker. Also coming up, Tim Tabik is going to be presenting at Jug Nord on using Open Rewrite together with machine learning. So if you are able to make it, I'm not even going to try to pronounce the name of this location. I encourage you to check it out. Machine learning is a hot topic, and applying it to manipulating your code is a fertile field for innovations. And then finally, Tim will also be at a Belgian Java users group. So if you're in Western Europe and want to see Tim, you have a lot of great opportunities coming up over the next few weeks to do that. Okay, and so without any further ado, let's get on to the main topic, the dependency vulnerability check recipe. Maybe I'll just start off with a brief demo for anyone who may not already be familiar with this recipe. So I'm going to just go run it through the Moderne interface and fix vulnerable dependencies. And so this recipe, as you are maybe already familiar with, will run across all of your repositories and compare the dependencies that it finds in there to, actually, let's just run it on the default group. Go ahead and kick that off. So this guy will run through all of your dependencies, both direct and transitive, and compare them to the GitHub Security Advisory database, which is a superset of the National Vulnerability Database, the source of truth for the CVE numbers we all know and love. And it tries to opportunistically suggest dependency updates wherever you're only a patch version away from from a version that the database knows to have a fix. And so if we go and check out the results, and this supports Maven and Gradle, and other build tool support will be added as well. Yeah, as you see here, this is managing the transitive dependency versions of in this case JSON Smart in order to bump it up to a patch version that has a fix. And let's see if we get a couple other results. Yeah, quite a few in here. Yeah, occasionally you get multiple CVE numbers at once with just one version bump. Or maybe I should put a line break in there or something in order to not scroll off the right edge of the page. Or maybe just after like 5 or 6 CVE numbers, just put a dot, dot, dot or something. So anyway, so that is the recipe. You may already be familiar with it. And those results might not look too different at first glance from what you're used to if you've already been running this, but the implementation has totally changed. But I guess before we dig into the implementation, I'll just briefly show the data table and the visualization that are built on it. Again, just for anyone who hasn't seen it already. So if you were a longtime user of this recipe, I appreciate your patience as I retread familiar ground for you. So yeah, in the data table produced by this recipe, it notes the full results, not just the results that it could easily change, or not just the results that were from patch version bumps, but all version bumps. So notes the CVE number, the GAV coordinates of the affected dependency, and whether it could be fixed just by bumping a patch version. And there are, so wherever there's a small, only a patch version difference, like we saw this result for JSON Smart, it suggests a code change. And I've been thinking about tuning this recipe so that it's have a configurable level of risk. Right now, patch version bumps are the only code changes it will attempt. But maybe if you were more comfortable with possible breaking changes and wanted to more aggressively move to update dependencies even when a minor version bump, or if you're really feeling like YOLO and just want to make all the vulnerabilities disappear from your reports, maybe even a configuration option to do major version bumps, although you would almost certainly run into breaking code changes on the regular if you did that. So if you would like that feature, if you're feeling more like you want to take the risky change and more aggressively move to uh, cut down the entries on your vulnerability reports, let me know. Say something in the community Slack, say something in a comment on this video, and maybe that leads to me prioritizing that enhancement to this recipe sooner than I would otherwise. Okay, so that is the gist of this recipe. And you might be like, well, why are you bothering to show us this? This is how this recipe has always worked. Um, like, what's new here? And so what's new is that I have almost completely replaced the implementation of this recipe, which again lives in the org that, like all our recipes, is an open source. So this guy lives under the Rewrite Java Dependencies project under the Open Rewrite organization and a class named Dependency Vulnerability Checks. If you want to check this out after this video, I'm not showing anything closed source. You can go look at it. You can contribute to it. You can give me a pull request that adds the option I described earlier if you're feeling really ambitious. So yeah, so almost the entire implementation has been ripped out and redone here in order to both fix a number of bugs or shortcomings it has and make the recipe more maintainable into the future. So let's talk about that implementation so that if you wanted to customize this, if you wanted to make your own version of this, you would have the knowledge to do so. So, for example, some of our customers, some of Moderne's customers, don't want to use like the GitHub Security Advisory database. Like they're like, we pay money for some other security scanning solution, white source or something. So we would like to use our security data source rather than the GitHub Security Advisory database, so that the results we get back exactly match what our other reports are telling us, just so there's no confusion to have to explain to other teams or to management about why you don't have exactly the same results. I would say that all of these dependency databases contain information from each other. They certainly all contain information from the National Vulnerability Database, the NVD. So the differences are probably not going to be huge, like if you were using a different vulnerability database from this one, but it could be a source of friction in a conversation that you might otherwise want to go more smoothly. So let's talk first, before we talk about the implementation of the recipe itself, let's talk about where the data comes from. Because having up to date data for this is really one of the most key things. And so to balance up to dateness of vulnerability information with with having like really fast execution time for the recipe, we actually do the update of the advisory database as a scheduled GitHub action, which runs on Mondays. Uh, that it will go check out the repository on CI, and it'll check out the GitHub advisory database, which is actually like this is an action is provided by GitHub, not one we came out with. So this is just a service GitHub provides to its users. So anyone who uses GitHub CI can take advantage of that. And then we configure a Git user in order to run a Gradle task called GitHub Advisory Database, which we can go see defined in the build.gradle in a minute here, which goes and uses the database downloaded in this step and uh, produces a CSV file containing all of the vulnerabilities relevant to the Java ecosystem, or the Maven ecosystem as it is recorded in the GitHub Security Advisory Database. Oh, and a similar update now that we've started to try and support C Sharp, a similar update for the NuGet repository for C Sharp dependencies. And it puts it into the source main resources CSV. And if you're familiar with the packaging and bundling of Java projects, which presumably you are if you're here, you know that anything you put inside of source main resources is going to end up bundled into the jar. So the recipe module for rewrite Java dependencies itself contains this CSV file, which you can actually go and browse directly in the repository. It has, how many entries are in here now? It has 8,000 entries for known dependencies in the Java ecosystem that you can browse through. So if ever I get a bug report of like such and such dependency, the dependency vulnerability check recipe should have updated this dependency or done something with this dependency. Why didn't it detect this vulnerability? One of the first things I do is come in here and check, is the vulnerability they're talking about, searching by CVE number or something, in the database as we have it currently bundled with the recipe. And so far it always has been, except for one time the automated process which updates this database was broken, so it got a little behind. But this has been successfully kept up to date ever since then. So let's see if we can take a look at the Gradle task. Yeah. Okay. So there's a Gradle task that calls this parse advisories piece of code, which looks like, is this actually built just from within? Yeah. So this shells out to a parse advisories class, which is actually built within the same project, which goes and runs this parse advisories class to parse the GitHub Security Advisory database into a CSV. So if you wanted to use an alternate data source, you could potentially like fork rewrite Java dependencies, or just create a new recipe in your own recipe module that used similar logic uh, to go download your vulnerability source and to parse it into some format that could be bundled with the recipe, and then change the recipe to draw from there instead. Now, it is also possible, if you have like a running server, that like recipes can issue HTTP calls, so you can call out to some server that you have running in your environment, and have the recipe make requests of it. Although I will point out that if you do have the recipe making requests, it's going to do that for every repository it runs on. So if you were to, say, example, use the Moderne SaaS to run a recipe on 1,000 repositories, you would be making uh, 1,000 requests at least to the service as each copy of the recipe when executing went to make an HTTP call. So it'll be kinder from a load balancing perspective if you use a data source that is embedded with the recipe itself, as we have done here, right? Having Since we only query the GitHub Security Advisory database once a week, it's pretty unlikely that we're going to get rate limited or cause any kind of operational problems for them. So keep that in mind if you're looking to customize this. So cool. So now we can kind of talk about the implementation of this recipe itself. And the first thing to point out is that it is a scanning recipe, which might not be maybe immediately apparent to you why this is a scanning recipe. As a little refresher for anyone who isn't already familiar with this, a scanning recipe is like any other recipe, except that it gets a chance to see every single source within the repository before it makes any changes. And that attribute of scanning recipes makes them particularly good for recipes which are going to generate reports or data tables, because you have a notion. You can tell when every file has been seen, and have a natural step in which to kind of aggregate data. uh, so we'll discuss that as we go. So the accumulator for this type, uh, this guy, in order to do the dependency manipulations, has to delegate to the Gradle and Maven dependency upgrade recipes, and each of those are scanning recipes due to some features of how those recipes work and the kinds of dependency updates they can do. Sometimes do span multiple files. On the Gradle side, one of the enhancements I made to this recipe and to upgrade Gradle dependency and Gradle parsing in general was to try to make it better able to update Gradle dependencies that are in script plugins. So if you have in your Gradle builds, you've got some script called dependencies.gradle, and all of your other projects apply, say apply from dependencies.gradle, and that's how they do their dependencies declarations. Since I overhauled this recipe, it should be able to update that separate freestanding dependencies.gradle script, whereas before the last the past couple weeks, the dependency upgrade recipes would not be able to do that. And the Gradle dependency upgrade recipe can also upgrade versions of Gradle.properties files. So that's why that has to be a scanning recipe. And similarly, in the Maven land, if you have a multi-module project and you have some dependency declarations in like the root POM, which all the others take as their parent, and you were doing a dependency upgrade, you just want that to go into the root POM, not individually into each of the individual module POMs. So because we're going to delegate to later on the dependency upgrades to two other recipes, which are scanning recipes. This recipe has to be a scanning recipe, and during the scanning phase of this recipe, we have to be sure that those accumulators are populated, and so those recipes can be used. And also on the accumulator is where we keep the vulnerability database, which in memory we load up into a map of group artifact coordinates to a list of vulnerabilities associated with all versions of that group artifact, and then we can with that full comprehensive database compare the group artifact and version of any dependencies we find in the project with the database in order to figure out if there are any known vulnerabilities with that or not. So there are a couple methods in here. One is the relevant one of upgradable vulnerabilities, goes and figures out a mapping of resolved group artifact versions to which vulnerabilities are relevant to those, so that you can easily say, am I, an upgradable dependency is one that is only a patch version away from the version you're on. So you can kind of see here the logic that's going to look through all the vulnerabilities, check, filter it down to just the ones that have a fixed version, where the database itself includes a fixed version. Compare using the latest .patch Simver class from Rewrite Core or from Rewrite Maven. And so if you ever wanted to say, check if a version of two dependencies is only like a patch version away. This is an easy way to do that. Comparing, saying latest patch is valid, the from version and the to version. So that can be relevant in a variety of dependency management contexts. So that's a neat thing to know how to do. And so if later on I expand this recipe to support like minor or minor version upgrades, right now we don't have like a latest minor version selector. So that's something I would just have to go add to rewrite Maven in order to support that expansion of functionality. Okay. And yeah, the vulnerabilities class is just keeping track of a mapping of coordinate to vulnerabilities. And in scanning recipe to get initial value, we see more of the logic involved with grabbing that advisory's Maven CSV out of the jar's resources, loading it up with the CSV reading library, and then chopping it up into the mapping that goes in the accumulator that we saw earlier. And so that is where the accumulator comes from. And then in the scanning phase, like I referenced before, we use this. The scanning phase needs to visit multiple types of files. It needs to visit Gradle.properties files. It needs to visit Maven POM files. It needs to visit Gradle scripts. And so we use a tree visitor, which visits all types, and then delegate to the scanners of the Gradle upgrade dependency version, or rather the the upgrade dependency version recipe, which supports both Maven and Gradle, and the upgrade transitive dependency version recipe, which also supports Maven and Gradle. And these both live in the same Rewrite Java Dependencies project. And if you go look at them, you'll see a similar kind of delegation pattern where they parameterize and then run those other scanning recipes. And then there's these scan Maven and scan Gradle Groovy methods, which just quickly look at the dependency metadata, which is on a Maven POM under get resolution result, and in a Gradle script is under get it's under the Gradle project marker, and then just compare those versions to the vulnerabilities that we've already populated into the database to figure out if anything is applicable. Okay, so after the scanning phase is done, every file in the repository has been scanned, every dependency, both direct and transitive, has been compared to the database, and we can know, before making any code changes, the full set of potential vulnerabilities, as well as the full set of fixable vulnerabilities. So between the scanning stage, where get scanner is called and runs through every source in the project, applying the scanner, then there's the generate step, which is technically it's named for its function, which is to produce new source files. This guy does not produce any new source files. As you can see, it returns collection.empty list at the end rather than producing a new source file of any type. But it does find the generate step a very convenient overload to take a breath between scanning and editing, to use it like an event. Like, hey, scanning is, if this method is called scanning is complete, you've seen every file in the project. So if you want to do any post processing, to figure out any statistics in aggregate, produce any data tables based on aggregate information, this is a good place to do that, and that's exactly what generate is used for here. Going through, in the scanner, we identified all of the potential vulnerabilities in the project. And so in generate, we just loop through all of those and add entries into that data table I showed you earlier. Yeah. And then when it's time to actually make code changes, we go down into get visitor, which, just like get scanner, needs to apply to source files of multiple different types. So it overrides tree visitor. And then it goes through all of the upgradable or the potentially upgradable vulnerabilities we found, and it calls upgrade dependency version on them. And upgrade dependency version only deals with direct dependencies which are declared explicitly within a build file. And we use this trick of checking referential equality to see if it made any changes. So, we have if we're entering in this code path, we have a vulnerability which should be upgradable. We're looking at a project that has that dependency. or we're looking at a repository at least that has a dependency, we're going to try bumping up. We're going to try bumping up the version, and if we call upgrade dependency version, and we're passing in t and assigning to this variable t2, and so because all LSTs are immutable, t will be unchanged from having been visited, and if t2 has any differences from t, if upgrade dependency version did its work successfully, then T2 will have a different, will be not be referentially equal to the original T. So we check if they are the same. Oops, didn't mean to replace that with the number 4. So we check if they are the same, and if they are, this means that upgrade dependency version was not able to do anything with this file. Maybe the dependency declaration was in a format it doesn't support or understand, or maybe it's a transitive dependency, in which case we should try applying the transitive dependency version recipe as well. And we repeat the same process of checking if upgrade transitive dependency version made any changes, so that we can say, hey, if changes were made, then this this dependency upgrade, uh, then a dependency upgrade was successful, and the set of vulnerabilities that were addressed by that upgrade can be recorded as fixed. And then we pass that into this commit message marker, which is, I think this is the only place that at least that I know of in the Open Rewrite code base, where this commit message marker is used. And this this adds just a marker to the LST, which suggests additional information for the commit message. Now, if you're using the Open Rewrite build plugins, you'll never see any effect from this, because the Open Rewrite build plugins don't do the committing part, right? Like, that's up to you as the user of the plugins to decide when you want to commit. But if you run this recipe in the Moderne interface and commit the results, because recipe running and committing are tied together there, then we are able to augment the commit message generated by Moderne with the information from this marker, which means that when you run in Moderne and mass commit the results of this recipe, the commit messages will include a listing of all the CVEs that are supposed to be fixed by these changes. So that's a handy little feature that's kind of buried in the framework, where if you were a user of the Moderne SaaS, you may find that really handy to augment your recipes with that, so that people looking at the pull requests and change lists and commits issued by your automation have that additional context. Let's see. So there's some more kind of implementation details of the recipe. Don't know that there's anything else in here that we really need to go in depth on. You can scan Maven and scan Gradle Groovy methods are just involved in comparing the dependency metadata attached recorded on the project to the database. And then there's a little bit of logic in here to try and do some error correction. Let's say one kind of common bug report that we got about this recipe before I changed it was that it would upgrade you to a version of a dependency that did not actually exist, and that was due to some slight messiness in the data source itself. So, like, in the vulnerability database, occasionally you would have, records like the minimum version that the fix or the minimum version of that dependency that is known to have that vulnerability, as well as the version it was fixed in, if a fixed version is available. And every now and then there would be a data integrity problem where, the actual version number as it appeared in Maven Central or other artifact repositories would include some kind of suffix, a dash JRE, a dash, release or whatever, that would not end up recorded in this database. And we were just kind of blindly trusting that whatever was in the database was about fixed versions was true, and just sticking that literal version number in there exactly and unchanged. And we found in at least a couple cases it was it was not it was not entirely correct. So one of the improvements I made to the recipe was to check if that dependency actually exists, and if it doesn't, then we just try upgrading to the latest patch version. because that will end up fixing all the same things, and be guaranteed to exist. So that is kind of a tour of the dependency vulnerability check recipe, with kind of a side primer on scanning recipes, how they work in general, how they're applied in this case, how you can integrate external data into a recipe by including it in the resources of your recipe module. So hopefully you found this interesting. Hopefully you were using this recipe on the regular to keep your dependencies up to date, and and I hope everything goes well for you during this Cybersecurity Awareness Month. Hopefully, cybersecurity is brought to your awareness not by a massive data breach or an outage of some kind, caused by hackers ransomwaring all of your most precious IP, but rather by reports that are green, saying that your dependencies are up to date and not particularly vulnerable, and that everything is just fine. Uh, so, without further ado, have a great week, everyone. I should be back next week. I believe Tim is scheduled to be back as well, and I don't know what our topic is going to be yet, but I know it'll be good. So I look forward to sharing it with all of you then. And until then, have a great week and remain security aware. Bye bye for now.